Hello and welcome to this spreadsheet developed by the navalarc.com, which can be used for fender design and selection of fenders for a particular berth. Basically, this spreadsheet calculates the berthing energy required to berth a particular vessel, and from this berthing energy we can select fenders which are capable of absorbing this berthing energy. It calculates both the normal and abnormal berthing energies. Abnormal berthing energy is for extraordinary berthing cases like storms or gusts of wind during which the vessel can hit the berth at much higher velocity and energy. We begin with a welcome sheet which shows the formula of the berthing energy. The formula is based on kinetic energy with some additional coefficients which we can see in the formula as Cm, Ce, Cc, and Cs. Cm is the added mass coefficient. This comes into play because when the ship is moving, it moves with a mass of water. This mass of water gets added to the mass of the ship. Ce is the eccentricity factor. This comes into play when the ship is berthing at an angle to the berth, because of which there's a mass of water trapped between the ship and the berth, which dissipates some of the energy. Cc is the berth configuration factor. It is different for different types of berths, which we will see later. And Cs is a softness factor. Depending on whether the fenders selected are soft or hard, the energy absorption capacity of the fender will differ. Once we have calculated all these factors, the final berthing energy required to be absorbed by the fenders can be calculated. From this normal energy, the abnormal energy is calculated by adding safety factor to the normal energy. This safety factor is taken as 2 as per British standards. This spreadsheet is based on certain codes and standards and guidelines. The PNWG 33 Guidelines for Design of Fenders, 2002, is used here. Then the BS 6349 Part 4 1994, which is the Code of Practice for Design of Fendering and Mooring Systems, is also used. And the third one is Recommendation of the Committee for Waterfront Structures, Harbors and Waterways, EAU 2004. Next we go to the Inputs worksheet, in which it asks for general particulars and the vessel particulars like the length, LBP, breadth, draft at full load and displacement at full load. Then comes the berth particulars, in which the first one is the type of berthing. There are two types of berthing, side berthing and end berthing. Figures are provided to explain what is side berthing and what is end berthing. Then second is the berthing condition, which is how difficult it is to berth at this particular location. There are 5 options: easy sheltered, difficult sheltered, easy exposed, good exposed, and difficult exposed. The third option is whether it is a tug-assisted berthing. The next input is the berthing speed. The berthing speed can be either entered by the user, or the user can click the Get Estimate button to get an estimate of the berthing speed as per PN 2002. Then next inputs are berthing angle, distance of point of contact from bow, and the available water depth. The latter 3 inputs are only applicable for the side berthing option. The last one is the berth configuration, in which we have got different options, whether it is a solid structure, a partly closed structure, or an open pile structure. Next is the fender particulars, whether the fender is hard or soft. Once all this is done, we just need to hit the button Calculate Berthing Energy, and this spreadsheet calculates the final berthing energy. In between, it calculates all the different factors mentioned before, like the added mass factor based on the formulas provided in PN and BS 6349. Then it calculates the eccentricity factor, which is because of the ship coming at an angle to the berth and the water being trapped in between, which gives a dampening effect and reduces the berthing energy. Next is the berth configuration factor, which comes into play because of the design of the berth. If the berth is a completely solid structure, then the water trapped between the vessel and the berth doesn't have an outlet, and so it has maximum dampening impact and reduces the berthing energy. However, if it is partly closed structure, then the water can go in, and so its dampening effect reduces. And if it is an open pile structure, then this water doesn't have any effect on the berthing energy. Next is the softness factor. This factor comes into play because of the softness or hardness of the fender. Basically, if the fender is soft, then it absorbs much more berthing energy and very less energy is imparted to the vessel. In that case, the softness factor is 1. But if the fender is hard, then it compresses less, it absorbs lesser energy compared to the soft fender, and some of the berthing energy is imparted to the vessel. In that case, the softness factor is 0.9 and the berthing energy required to be absorbed by the fender is less. Once all these factors are calculated, the final berthing energy is calculated by the spreadsheet. The spreadsheet calculates the normal berthing energy and the abnormal berthing energy, which is for abnormal cases like storm when the vessel hits with higher speed. For that, a safety factor of 2 is taken based on BS 6349. Once this berthing energy is calculated, the fenders can be selected to absorb this normal berthing energy and the abnormal berthing energy. Normal berthing energy is to be absorbed by the fender for normal operations which are very frequent and day-to-day operations, while the abnormal berthing energy is also required to be absorbed by the fender with as little damage as possible. That was about the fender design berthing energy calculation spreadsheet designed by the navalarc.com. To download the spreadsheet, please visit the website, and please provide us your valuable feedback. Thank you very much.